Hi everybody, today we're going to talk about quadratic functions, and the first thing I think you're going to notice is that we've talked about quadratic functions before. We've used them to do transformations, but today we're just going to look a little bit closer at quadratic functions and look at some properties they have that we haven't really used yet. A quadratic function can be written in the form f of x equals a times x minus h squared plus k. hk is the vertex. A is going to tell us a lot of information about our quadratic. When A is positive, we're going to know that f of x opens up. It will look something like this, and that will give us a minimum at this vertex of hk. When A is negative, then we know it's going to get reflected and it's going to up and down, and then it will have a maximum at hk. So just this little picture tells us a lot about our quadratic. So let's start just by finding the vertex and state if it's a max or a min. So I have f of x is 3 times x minus 2 squared plus 4. So my vertex is going to be at 2, 4. Because 3 is positive, I know that this quadratic opens up, so this vertex of 2, 4 will be a minimum. This time I have f of x is negative 5 times x plus 1 squared minus 2. So let's start with the vertex. The plus 1 becomes negative 1. The negative 2 stays as negative 2. The A this time is negative 5. A negative says I had a reflection, so now it's opening down. That makes this vertex a maximum. So let's add some more stuff to this quadratic, and we're going to start with the axis of symmetry. What I want you to think about is x squared is an even function, and even means I have the same thing on the right and on the left. So there's this repetition of the function, and the symmetry, when we're looking at even functions, is talking about being symmetric to the y-axis. So what's on the right side of the y-axis is the same side as the left of the y-axis. As we do transformations, we're going to retain symmetry, but where the function's symmetric is going to change. So it won't be symmetric to the y-axis. It's going to be symmetric to a line x equals h. X equals h is a vertical line that goes through the vertex. As you're writing the axis of symmetry, it's really important that you always write it as an equation. So never just telling a number, you always want to say x equals a number. Important features to look at with this even function says, when I have x-intercepts, they should be the same distance away on the right and the left of this axis of symmetry. So when I look, that kind of is a nice little verification of they should be an equal distance on each side. The same kind of thing, the y-intercept will have a duplicate number, so there'll be another number on the graph that has the same y-coordinate as the y-intercept. It will be the same distance away from the axis of symmetry as the y-intercept. So kind of a nice way to verify that you did the graph right. It also gives you multiple points to use when you're trying to graph the function. So let's try. F of x is x minus 1 squared minus 9. The vertex is at 1, negative 9. This is opening up, so I know this is a minimum. Domain of all quadratics is negative infinity to infinity. The range is going to change, and knowing this vertex is going to be really helpful. So having a minimum value for our vertex says the smallest it'll ever be is negative 9, and it goes to infinity. Axis of symmetry, which often we write as AOS, is x is equal to 1. The y-intercept comes from calculating f of 0. So I have 0 minus 1 squared minus 9. 0 minus 1 is negative 1. Negative 1 squared is 1. 1 minus 9 is negative 8. So I have a y-intercept at 0, negative 8. And then my x-intercepts. I get that from setting the whole function x minus 1 squared minus 9 equal to 0. This says x minus 1 squared is 9. We're going to take the square root. Super important, when you take the square root, x minus 1 is going to be positive or negative 3. I'm going to separate that into x minus 1 is positive 3, x minus 1 is negative 3. This says x is 4. This says x is negative 2. So I have 2.40 and negative 2, 0. Now we want to add all of this information to our graph. The first thing I noticed is I didn't give myself enough room on this graph, and I'll just do my best to draw this in by hand. My line won't be perfect, but I'm going to skew it a little to give myself extra room to get to this negative 9. So go over 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my vertex. From there, I'm going to use my x-intercepts. So I have 1, 2, 3, 4. Here's an intercept, and then I have negative 2. Here's another intercept. My y-intercept was negative 8, And if we wanted to, a nice thing we can do is go ahead and put in the axis of symmetry, and I'm going to put that in as a dashed line. And I'm just going to say if I had a point 1 to the left of the axis at -8, then I'm going to have a point 1 to the right of the axis at -8. Now we're going to connect the dots. This is the worst part for me because I'm not a very good artist, but you'll get the overall idea, and I promise I won't draw them all. Try it again, a little different graph. I have f of x is -2 times x plus 3 squared plus 8. Like last time, we'll start with our vertex. It's going to be -3, +8. I have a -2, which tells me this is flipped upside down, so this now is a maximum. My axis of symmetry, AOS, is x equals -3. It always matches the h coordinate from the vertex. The domain is -infinity to infinity. And then the range, the maximum it's going to be is +8, so I want to say -infinity until 8 and then a square bracket. I wrote find the y-intercept, but in actuality I want to find all intercepts. So let's do f of 0 is -2 times 0 plus 3 squared plus 8. So this is -2, 3 squared is 9 plus 8. So I have -18 plus 8 is a -10. To get my x-intercepts, I'm going to take -2 times x plus 3 squared plus 8, set it equal to 0. First step is move the 8 over, so I have -2 times x plus 3 squared is -8. When I divide by 2, I get x plus 3 squared is 4. I'm going to take the square root of both sides, so square root of x plus 3 squared, square root of 4. I have x plus 3 is plus or minus 2. So if x plus 3 is 2, then x is -1, so I have the point -1, 0. If x plus 3 is -2, then x is -5, so I have -5, 0. Let's draw this graph. Now let's look for 1 second at what our vertex was. It's -3, 8, so I know I need some space to draw the 8, and I also had a y-intercept that was -10, so I kind of want to make sure I get all that onto my graph. So 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's start with the 1, 2, 3, -3, +8, there's my vertex. Let's put in the x-intercepts. I have one at -1, and I have one at -5. I'm going to draw that axis of symmetry in so I can show you 2 on the right, 2 on the left is equal. Our other point that we want to put in is our y-intercept, and remember that was way down here at -10. I'm 1, 2, 3 over, so 1, 2, 3 over. If I want to go one more and put another dot, I could. It might help us draw. So I'm just going to try to connect these dots the best that I can, right? Thank goodness for technology. It says list the vertex, axis of symmetry, intercepts, domain, and range. So, like the last couple, I'm going to start with the vertex, which is 1, +3. It's going to open up, which means it has a minimum. And the minimum value would be 3. So when I look at the domain, it's -infinity to infinity. And when I look at the range, it's 3 to infinity. Now, I want to point that out right now, just to kind of show you something really quick. Let's put in 1, 1, 2, 3. I want you to picture, here we are at 1, 3, and I know I'm opening up. I'm going to draw and then erase. I'm not going to have x-intercepts on this particular graph. When I'm looking at the point that 3 is my minimum and I'm going up, there's no way that it's ever going to have a value where y is equal to 0. X-intercepts, none. We will still have a y-intercept, which means I'm going to do 5 times 0 minus 1 squared plus 3. 0 minus 1, -1. Squared is 1 times 5 is 5. 5 plus 3 is 8. Let's erase my little drawing so we can put in, this is 3, 4, 5, 6, 7, 8. So here we are way up here at 8. Let's say our axis of symmetry, which is x equals 1. And now we can finish off the graph. Now notice this time I only have 2 points. I have a y-intercept and I have the vertex, which makes this axis of symmetry really helpful. When I put in the axis of symmetry, I compare that I went 1 to the left and I was up here at 8. So if I go 1 to the right, I will have a second point. These 3 points help me draw this curve with some kind of accuracy.